Okay, so you all marked your x-axis with a yellow flag. Now I would like for you to plot, right? Plot the point 5, 4, 0 with your flag, and then tell me a story about 5, 4, 3 and 5, 4 minus 3.
Okay.
All right.
5, 4.
So first is 5, 4, 0.
4.
And you can assume
I think we
that
need
you're
the
giving
tape,
me
Yeah, we
though.
need the tape. That's what we have.
Yeah.
The tape.
So, in inches, are we?
We can make approximations, dude. You don't.
Yeah, except
Maybe measure the whole
Except-
thing first.
these are 3 feet. Okay. 3 feet, more or less.
So we're doing this in inches.
We're doing it in centimeters.
Centimeters.
We're actually doing it in millimeters.
Please don't do it in inches. Feet.
Yeah, of
Aren't
course.
these
we're
only
doing
3
it
feet
in
long? Aren't these only 3 feet long?
They are. They're the idea of axes. They're not
Okay.
actual axes.
Oh, okay.
Actual axes would be hard to carry down here since they're extremely long.
They'd be infinitely.
Yep. 5, 4, 0.
Bam.
Tell a story about 5, 4, 3, 1, 5, 4.
You might want to pull that a little bit closer to
Oh
the...
yeah. Tell me where 5, 4, 3.
There you go. Better. Right there.
Right, because right now you have 5, 4, 0, right?
5, 4, 3
5,
is
4.
levitating about 3
Yeah,
feet.
and
5 foot negative 3 is down the ground.
Nice.
Now, how do we do the z-axis?
Zero.
Yeah.
Okay,
5,
so
4, 0.
So all of you figure out
On the
that
ground.
5, 4, 0 is, very nice. That's what I want to see. You guys see that? So Kaz has 5, 4, 3 marked right here.
Got it?
And where's 5, 4 minus 3? Yeah, you need a shovel.
You're gonna need...
But is it attainable? Could we dig to 5, 4 minus 3?
Yep.
Oh yeah. As long as we don't find a rock.
Yeah.
Could we, with a sufficient amount of shoveling and dynamite, dig to 5, 4 minus 3? Cool?
Perhaps.
Okay, so that was a Cartesian point, right? You guys want to try another one, or are you comfy? Yeah, we got hours. Let's do another one. So can you guys plot -2, -3, 1
On what? Just the
on your axis? Yeah, on the Cartesian.
minus 1, minus 3, 1?
-2, -3, 1.
Okay. Minus 2, minus 3, 1. But 3 feet up in this one. I know, like, I have no consolation.
Minus 2, minus 3?
-2, -3? -2, -3.
Where's minus? Move your thing over a little bit like that.
Just trade off. It's fine. Take breaks, stand the shape.
And then pull up.
1.
Yeah?
And then we're going to put the top to whatever my height is.
Cool.
So there's a little over.
Nice. So you went back to, over to the wrong way, right?
Oh, really?
Then back, then up.
The flag's at the height.
Yep.
The flag is
Cool. Very nice.
It's the flag, not the stick.
Yeah, that's perfect. All right, then can you guys tell me the coordinates of your yellow x-axis marker flag?
How many feet?
Oh.
Yeah, measure the length.
Yeah, so X 0, 0.
We can guess.
Should be
Should be just x...
5, 0.
No, 300 because it's 3 feet. So yeah, 300.
Okay. So 5.
Well, there's positive.
Just double check to make sure.
Positive 3. Yeah. And then negative 1-ish.
Well, it's a little over 3 because
Positive.
a little over 3, but
That's not
it's about 3.
Okay.
He wanted okay, so feel free to round a little bit if needed. But what are the coordinates of your yellow x-axis flag?
300.
0, 0.
3, 0, 1. maybe 1 to the top of the flag and 0 to the bottom.
Top of the flag, 1.
Yeah.
Okay, so can you guys write me an equation, now that you know that, in Cartesian for the x-axis? Yeah, so tell me about the x-axis.
Y equals 0, Z equals 0.
You guys see that? This is 3 dimensions, right? So I can't write a line equation with 1 equation, right? I need 2. Well, we'll have a way later, but for right now, I don't have a way to do that, right? You guys see that?
Oh, so you're just making you have 2 equations going on one, so that's 1 equation.
Yeah, so what is the equation y equals 0? What does that look like in your Cartesian grid? Can you plot that? No. The x-axis is...
Because that'd be
It'll
a
be
plane.
it'll be the YZ.
It would be a plane on
So,
the y.
what does y equals 0 look like?
It'd be like
Or X.
Down,
this.
Yeah.
exactly.
right.
Yeah.
Something on this.
So,
Flat.
the only thing, right, that you know any information about is that the y is 0, right? That puts you here. You know nothing about x or z, right? So you can go out or back, right? Or up and down, whatever. Exactly, like a curtain that goes forever through these 2 axes. You guys see that? So there's our first equation of a plane, right? You guys see it?
Yep.
Yeah. So what are the equations for the other 2 planes? Can you guys tell
X
me that?
equals 0.
X equals
X is 0, so what does X is 0 look like on your...
the YZ plane.
Yeah, so just X is 0 looks like the which plane?
The YZ.
The YZ plane, right? Because Y and Z are both free, but X is 0. That's cool? Alright, what's the other one?
Z equals 0.
The ground? Z is 0. That's the one I should have started with, right?
Yeah.
Cool? Alright, you guys want to try cylindrical?
Mhm.
Okay, so...
I wish I could see it through the camera. I have no idea where I'm looking.
Plot.
For all I know, I'm missing half of the picture.
No, you're fine. That thing's got a really wide lens on it.
Okay,
You're
good.
pointing where you're pointing your head.
So can you guys on
So-
cylindrical plot, or in cylindrical, plot 2 pi over 4, 1? 2, comma, pi over 4, comma, 1.
That's half a. That's an eighth of a rotation around a unit circle. Yeah, pi over 2 would be. Okay. So then it's going to be like this. And then, what were the other?
2, pi over 4, 1, and cylindrical.
It's cylindrical. Yeah. So then it's going to be pi over 4, which is like this. Yep. Up to. Well, the radius is going to be.
Yeah, the radius is 3.
But, so you got to measure it like this.
Yeah,
Right? No?
that radius isn't cylindrical, or isn't spherical.
yeah.
It's cylindrical, the radius sits in the XY plane.
The radius.
Yeah, so then it'll be like this, and then just take it up 1.
Yeah.
Oh, right.
I know, it takes like 20 so we got 2.
Yeah.
So now we have to find the
2's like
angle of 2 pi over 2.
yeah, or pi over 4.
No,
Yeah,
No,
it's
no,
going to be halfway.
like three trains going on. Where like one
Yeah, I'm willing to go with both.
and then you have this other like
Right.
going
That
on.
was
Yeah, because
circle, and then a quarter of the way through the unit circle. This would be pi over 2.
Yeah, pi over
This would be pi. This would be
Yeah, yeah,
pi over 3.
okay.
And that'd be
I see it.
And then actually this would be 2 this way.
and
Very cool.
And then
you have to go up.
Okay.
Yeah, and then you go up 1, right, which is about the tip of the flag. You guys see that? So the crucial thing in cylindrical, right, is that the radius has to sit in that XY plane.
so literally
Okay.
you ignore R until you figure out the Delta. Until you figure
Yeah.
out the delta. You didn't finish. You didn't let me
Yeah,
finish my sentence.
You change the angle first, then go out the radius, then go up.
Okay.
All right. Can you guys tell me about the coordinates of that?
Okay. Oh, okay. That's
A little easier.
Yeah, we're on.
so that's pi.
Guys, tell me about
Let's assume that's pi.
Yeah, this is pi.
Yeah.
That's cheating.
Pi.
Oh, actually, a little more.
Measure the radius.
Yeah. So it'd be something pi.
5.5 feet, right? Hold it to. Alright, so that's right to.
Almost 6.
Yeah. 6 pi.
1.
Yeah,
6 pi 1.
Or it could be 0. So that's. Or you could even have interval notation because
Okay.
it'd be from 0 to 1. That
Oh yeah. Okay. So
technically,
Well, actually, no. I think it'd still be positive.
These are just split it.
Well, or we could do -6. It could be -6, 0. No, it'd be -6.
No, it'd still be positive because it's just a radius, period.
Yeah.
And your radius
You
can't
guys
be
are having
negative.
the same conversation about signage, right?
Yeah.
Are you guys also having? Okay.
The only thing that could probably change sign is z, because radius always is positive.
Okay. So let's
Measure at 0.
come over here and gather up for a second. I want to make sure that this conversation is clear because
We would have to go into a little different dimension in order to have a negative radius.
yeah, and this is the thing about cylindrical, just like polar, you can record the coordinates for the same point in multiple ways, right? Because there's some ambiguity with the idea of angles. So this one in particular, right? So this is on the x-axis, right? Or at least above the x-axis.
Stop making me shake my head up and down.
Okay. So, what's the angle I need to go around to get to this pi? Okay, would minus pi also work?
Yeah.
Would 3 pi also seems like it would work? Crap.
Pi. Yeah.
There's some ambiguity. So, let's pick one. Let's say we're doing pi, because all of you guys said that first, right? So if I go pi around, then this distance from 0 to the bottom of the flag is how far?
6.
You guys measured 6 on yours? Okay, so this one we measured 6. Now is it plus 6 or minus 6?
Plus 6, because a radius cannot be negative.
could be minus 6 though and have a negative.
But that means it could be minus 6, but not have a negative angle, have a 0 angle. Right, you guys see that? If I went 0 off and 6 backward,
Oh, true.
I'd get to here. But if I choose that, I'm going to go to pi, then I got to go out 6. Because if you go pi and minus 6, where's that?
Back that way.
Back over there. And then what do you do with the Z on this flag? To get to the top of the flag? Yeah, just however tall the flag is.
Which is 1.
1, probably.
So
Cool.
do we get to choose what we want to do?
Yeah, of course you get to pick, right? I would recommend that you make good choices, but I'm not going to quantify what good choices mean. You guys should have enough practice with angles at this point to know it. That like picking 7 pi would be kind of a crumb choice. Cool? Questions on that? All good? Alright, can you guys as a group give me a good set of coordinates for this?
So
And
that's
go 12 feet underground there.
it's pi plus a 4, or yeah, plus a 4.
So R looks like it's about 4, right?
5/4 pi,
Okay, where'd you get 5/4 pi?
because it's pi right there, and then you get one more quarter.
Pi and 1 more quarter. It's kind of more like cool.
30 degrees. It's more of a third,
Like
yeah.
7 pi over 6.
Well, are you assuming
I
it's
was going for pi over 4. Okay, get a protractor out, right? Okay. So let's assume it's pi over 4, and then what do I do about that 12 feet underground? Negative 12. Cool? Cool. Good? Alright, you guys want to try the other one?
sure?
The other coordinate system, right?
It's gonna be a
Okay, so-
nightmare with the flag, but okay.
Is there anything crucial we had to remember about Cartesian? That was pretty much the... What?
V is from the Z.
Oh, no, how about Cartesian?
Oh.
I'm just trying to review before we move to the next one.
Oh, we're gonna.
Was there anything crucial in Cartesian that was confusing?
No.
Not really. You guys understand that minus just means go the other way, right?
Yeah.
Okay, so we're good on that.
Straightforward kind of
How about
procedure.
cylindrical? What's the crucial thing you have to remember?
Start with the radius.
Multiple
or the-
angles. X marks.
Start with the
Yeah, you got to remember there's multiple angles, and that theta starts off the x-axis, and the radius is in the. Where's the radius measured?
From the origin.
It's measured.
From the origin. Distance from origin.
Oh, sorry. The radius, yeah, is distance from the origin, but it's in the x-axis.
Oh.
Okay,
You guys
that's
remember that? That radius is flat.
Yeah, X, Y.
Right, so my minus 12, maybe let me pick a positive one. Here's a point, right? The radius for this point is not the distance from this to 0, right? It's the distance from flattened out to 0. Okay, see that? Yeah, the radius is a thing in the XY plane.
we're gonna need both our flags or this.
Okay. Ready? Set. Alright, give me 4 pi over 2 pi over 2.
So 4 pi over 2 pi over 2. So measure out a 4 real quick.
Oh, thanks. My point and flag?
We can just guesstimate 4. So we got 4.
Yeah, and you can estimate 4 a little bit. I think you guys know how to do that.
Oh wait, no, 4 comes out last. So pi over 2 is somewhere in here,
Yeah.
Yeah.
Then the
Yeah, it does.
and then pi over 2. You're gonna need to use that flag pointed at an angle of pi over 2.
Pi over 2 is
Here, can I, real quick?
off of what?
Pi over 2 is.
Pi over 2 is like this,
No, but it's in between the.
and then
What's the angle?
measure
pi
out.
over 4, guys?
That's
Or-
pi over 4. This
Yeah.
this is X.
So
Oh, sorry, pi. Sorry, sorry.
Okay, so which
I was
angle
trying to.
pi over 2 is in between here and here.
Yeah.
So it should just be.
That's pi over 4.
No, it's pi over 4. That's what he was saying just a second ago. So it's a halfway point. Okay. So this would be pi over 2, and then measure out 4.
Right.
yeah, right here. So it's gonna be 4 feet it's right here. You got one. Okay. And then now we have to start from the z-axis down.
No, it's already. So this entire plane is our
Oh yeah.
this little angle plane.
And because it's gonna go from this.
Yeah, it starts.
So
We needed
you
both.
got, I'm buying you got a distance of 4 there from 0.
Yes.
Straight to the bottom of your flag. Okay, and you got the theta of pi over 2, so that put you someplace in this, right?
Yes.
Now you have to start from
And now you need to start from the top and go down
Pi over 2.
pi over 2, so that
Which-
gets you to.
Oh, so that actually is flat. So we don't actually need that at all.
So it gets you to the bottom of the flag there. See? So this angle's pi over 2. This angle's pi
I
over
still was doing the.
and
I
that
still was doing.
radius is 4.
I was still doing the pi over 4 was pi over 2 thing on accident.
Pi over 2.
Pi over 2, pi over 2.
It's gonna be straight.
So you guys got something off the end of the y-axis? Off the end of the y-axis?
Alright.
Nice.
So does that mean on a spherical, it's never going to be higher than the XY plane?
Ah. How would I get to... So, how would I get to the point that you guys have plotted, but down a bit?
Yeah.
Yeah, you'd go angle more than pi over 2. Please note, there's even more ambiguity in this system. You guys see that? Okay, so...
And the computer uses this system now.
Yeah, they do, some of them. So can you guys tell me, or plot me the point? Let's go 4 again. Pi over 4, pi over 2.
Yeah, so what we were trying to do last time.
What was the last one? Yeah, so it's still going to be the same. Yeah. So then,
We abandoned the made 4, right?
nope, that's fine.
It's good enough to
Okay.
Sweet.
Yeah, so yeah, pretty much what we tried to do last time.
Something like
Cool.
Feels like it should be a little bit more this way.
Now
Yeah.
plot the point.
Has a margin of error.
Yeah, with a new flag. Plot the point. 4 pi over 4 pi over 4.
4 pi over 4. So now you do what I was trying to do last time.
Should be like right here somewhere.
I know, but just use this as an angle marker. So it'd be like this.
Yeah.
You still got to indicate how far out.
Yeah, so somebody hold their finger there.
Right. Or, yeah.
should do pi over 4.
4 pi over 4.
Or 4 feet.
Hold the flag. That's what I want to see.
Right there.
So, all of you, right, should be noticing something about the 2 points you just plotted, right? What is it? They're in the same arc, right? But they're not vertically aligned. You guys see that?
Right.
Why aren't they vertically aligned?
Because that would be like making a circle straight.
Yeah, because the radius, right, the distance from 0 is the same. So if you tip it up, it's going to have to lose some in that xy plane distance. That's cool? Cool. All right. Let's kill that.